Black holes may sound like science fiction, but there is significant evidence to prove they are real. In this video, I will explain the reasons that prove we know how black holes exist in space. Also, I have written the sources in the description section, and anyone who wants can examine them in detail. Of all the far-out concepts in astronomy, black holes may be the weirdest. A region of space where matter is so tightly packed that nothing, not even light itself, can escape. These dark behemoths present a pretty terrifying prospect too. With all the normal rules of physics breaking down inside them, it's tempting to dismiss black holes as the stuff of science fiction. Yet there's plenty of evidence, both direct and indirect, that they really do exist in the universe. Einstein's robust prediction. As a theoretical possibility, black holes were predicted in 1916 by Karl Schwarzschild, who found them to be an inevitable consequence of Einstein's theory of general relativity. In other words, if Einstein's theory is correct, and all the evidence suggests it is, then black holes must exist. They were subsequently put on even firmer ground by Roger Penrose and Stephen Hawking, who showed that any object collapsing down to a black hole will form a singularity where the traditional laws of physics break down, according to the University of Cambridge. This has become so widely accepted that Penrose was awarded a share in the 2020 Nobel Prize in Physics for the discovery that black hole formation is a robust prediction of the general theory of relativity, gamma-ray bursts. In the 1930s, Indian astrophysicist Subramanian Chandrasekhar looked at what happens to a star when it has used up all its nuclear fuel, according to NASA. The end result, he found, depends on the star's mass. If that star is really big, say 20 solar masses, then its dense core, which may itself be 3 or more times the mass of the Sun, collapses all the way down to a black hole, according to NASA. The final core collapse happens incredibly quickly, in a matter of seconds, and it releases a tremendous amount of energy in the form of a gamma-ray burst. This burst can radiate as much energy into space as an ordinary star emits in its entire lifetime. And telescopes on Earth have detected many of these bursts, some of which come from galaxies billions of light years away, so we can actually see black holes being born. Gravitational waves. Black holes don't always exist in isolation. Sometimes they occur in pairs, orbiting around each other. When they do, the gravitational interaction between them creates ripples in space-time, which propagate outward as gravitational waves, another prediction of Einstein's theory of relativity. With observatories like the Laser Interferometer Gravitational Wave Observatory in Virgo, we now have the ability to detect these waves. The first discovery, involving the merger of two black holes, was announced back in 2016, and many more have been made since then. As detector sensitivity improves, other wave-generating events besides black hole mergers are being discovered, such as a crash between a black hole and a neutron star, which took place way beyond our own galaxy at a distance of 650 million to 1.5 billion light-years from Earth. Invisible companion. The short-lived, high-energy events that produce gamma-ray bursts and gravitational waves may be visible halfway across the observable universe. But for most of their lives, black holes, by their very nature, will be almost undetectable. The fact that they don't emit any light or other radiation means they could be lurking in our cosmic neighborhood without astronomers being aware of it. There's one surefire way to detect the dark beasts, though, and that's through their gravitational effects on other stars. When observing the ordinary-looking binary system, or pair of orbiting stars known as HR 6819 in 2020, astronomers noticed oddities in the motion of the two visible stars that could be explained only if there was a third, totally invisible object there. When they worked out its mass, at least 4 times that of the Sun, the researchers knew there was only one possibility left. It had to be a black hole, the closest yet discovered to Earth, a mere 1,000 light-years away inside our own galaxy. X-ray vision. The first observational evidence for a black hole emerged in 1971. And this too came from a binary star system within our own galaxy. Called Cygnus X1, the system produces some of the universe's brightest X-rays. These don't emanate from the black hole itself or from its visible companion star, which is enormous, at 33 times the mass of our own Sun, according to NASA. Rather, matter is constantly being stripped from the giant star and dragged into an accretion disk around the black hole, and it's from this accretion disk, NASA said, that the X-rays are emitted. As they did with HR 6819, Astronomers can use observed star motion to estimate the mass of the unseen object in Cygnus X1. The latest calculations put the dark object at 21 solar masses concentrated into such a small space that it couldn't be anything other than a black hole. Supermassive black holes. In addition to black holes created through stellar collapse, evidence suggests that supermassive black holes, each millions or even billions of solar masses, have been lurking in the centers of galaxies since early in the history of the universe. In the case of so-called active galaxies, the evidence for these heavyweights is spectacular. According to NASA, the central black holes in these galaxies are surrounded by accretion disks that produce intense radiation at all wavelengths of light. We also have evidence that our own galaxy has a black hole at its center. That's because we see the stars in that region whizzing around so fast, up to 8% of the speed of light, that they must be orbiting something extremely small and massive. Current estimates put the Milky Way's central black hole somewhere around 4 million solar masses. Spaghettification. Another piece of evidence for the existence of black holes is spaghettification. What, you might wonder, is spaghettification? It's what happens when you fall into a black hole, and it's pretty self-explanatory. You get stretched out into thin strands by the black hole's extreme gravitational pull. Luckily, that's not likely to happen to you or anyone you know, but it may well be the fate of a star that wanders too close to a supermassive black hole. In October 2020, astronomers witnessed this shredding, or at least they saw the flash of light from a hapless star as it was ripped apart. Fortunately, the spaghettifying didn't happen anywhere near Earth, but instead in a galaxy 215 million light-years away. And finally, a direct image. So far, we've had plenty of compelling indirect evidence for black holes, bursts of radiation or gravitational waves or dynamical effects on other bodies that couldn't have been produced by any other object known to science. But the final clincher came in April 2019, in the form of a direct image of the supermassive black hole at the center of active galaxy Messier 87. This stunning photo was taken by the Event Horizon Telescope, a slightly misleading name because it consists of a large network of telescopes scattered all over the world rather than a single instrument. According to NASA, the more telescopes that can participate and the more widely spaced they are, the better the final image quality. The result clearly shows the dark shadow of the 6.5 billion solar mass black hole against the orange glow of its surrounding accretion disk, as reported by Live Science. So what's inside a black hole? In some ways, that's one of the most profound questions in physics, said University of Chicago Prof. Daniel Holtz. There are not many cases in physics where we simply cannot predict what happens, but this is one of them. Black holes have two parts. There is the event horizon, which you can think of as the surface, though it's simply the point where the gravity gets too strong for anything to escape. And then at the center is the singularity. That's the word we use to describe a point that is infinitely small and infinitely dense. We have a good understanding of what the event horizon looks like, thanks to the laws of general relativity. But as you get close to the singularity itself, we lose the ability to even predict what it looks like. Very near the singularity, one would expect quantum effects to become important. However, we don't yet have a quantum theory of gravity, or at least one capable of reliably making such predictions. So we just don't know the correct description of the singularity, or even whether it really is a singularity, said University of Chicago Prof. Robert Wald. Scientists think that black holes eventually will explode, but it will take many, many times longer than the current age of the universe for that to happen. What will it look like when that happens? That's another big mystery. Maybe there's a little nugget left behind containing all of the information that fell into the black hole. Maybe there's a portal to a new universe. Maybe the information is just gone forever. We simply don't know, said Holtz. If all of this is unsatisfying, know that it keeps scientists awake at night too. How do black holes form? Scientists know about one way that black holes form, but there may be others. One way to make a black hole is to have a massive star collapse at the end of its life. Professor Subramanian Chandrasekhar was the first to calculate that when a massive star burns up all its fuel, it will collapse. The idea was ridiculed at first, but other scientists calculated that the star continues forever to fall inward toward its center, thus creating what we called a black hole. Black holes can grow more massive over time as they eat gas, stars, planets, and even other black holes. There's another type of black hole called a supermassive black hole. These are way too massive to have been created by one star collapsing. It's still a mystery how they form. Black holes can eat other black holes, so it's possible that the supermassive ones are made of many small black holes merged together. Or perhaps these big black holes were especially hungry and ate so much of their surroundings that they grew to enormous size, said Professor Holtz. But we can see these supermassive black holes formed very early on in the universe, maybe too early to have been made by stars getting old enough to collapse. So it's possible there's some other way to make a black hole that we don't know about yet. As we journey through the mysteries of the cosmos, the existence of black holes remains one of the most fascinating topics. Today, we've explored the compelling evidence that leads scientists to confidently assert the presence of these invisible yet powerful entities in our universe. From bending light to the gravitational effects observed in the cosmos, black holes continue to intrigue and challenge our understanding of space. Remember, the universe is full of wonders waiting to be discovered. Keep looking up and questioning the unknown. Until next time, keep exploring the mysteries of space with us. Don't forget to like, share, and subscribe for more cosmic adventures.